Section 6 is called Factoring ax squared plus bx plus c. In the last section, we were doing just x squared plus bx plus c. So the difference here is the fact that we have this number now in front of the x squared term that isn't 1. Before it was just 1. Now it's going to be 2 or 5 or 8 or 4 or 3. Okay? There's going to be a number in front of the x squared term. We cannot do what we were doing before with problems like this. We have to do something different. You can't just undo FOIL here. In the end, that is exactly what we're doing, but we can't do it the way we were doing it before. So, we know how to factor things that look like this, just x squared plus bx plus c. But what if we have a number in front? So now we have ax squared plus bx plus c. For example, 2x squared plus 5x plus 3. How do we factor that? We don't know how to do that yet. That's what we're going to do in this section. We're going to learn how to handle a situation like that. If you go back into section 5, you'll notice that every single problem that you were working on did not have a number in front of the x squared term. None of them did. But now they're going to. So how do we do that? Well, there's a few different ways to factor expressions that look like that. Just depending on your teacher, depending on the book, depending on lots of things, you could learn any one of those few ways to solve a problem like this. I'm going to teach you the easiest one there is, only. The book has a different way that they teach it. Some other teacher in the building, maybe they have a different way that they teach it. I will only teach you the easiest possible way to do it. And I'm telling you that it's the easiest way because it is the easiest way. It takes the least amount of time, it takes the least amount of space, and it will take the least amount of your eraser and your pencil lead to solve the problem. The book's method is, honestly, pretty terrible. It's usually like, it amounts to guess and check. And you'll be writing a bunch of stuff down, and then you'll make a mistake, and you'll have to erase a whole bunch of things and start over, or start like halfway over, and then do it all over again, and then you'll write a bunch of stuff down, and then you'll find out that you made a mistake, and then you got to do it all over again. And that can go on 3 or 4 or 5 times using half a sheet of paper or more coming up with the answer. What I'm going to teach you will take you maybe 3 lines on your homework, and you will not have to erase anything unless you make a careless mistake. But there's no guess and check. It's straightforward, and you wind up with the answer immediately. And that is a powerful thing. And that's why I'm just going to teach you this method. It's not in the book. So if you don't understand what I'm doing here, you'll want to ask questions, you'll want to review your notes, you'll want to watch this video. The method I'm teaching you is called the area method. It's the box method over again. It's just that we're going the other way. So we'll draw a box, but this time we're going to put terms in the box, and we're going to pull stuff out to make the stuff outside that we would have foiled in the last couple of sections. So it's called the area method, but you'll hear me say the box method. Set up the box. That's what I'll be saying. Okay? So, as usual, I'm going to give you all the steps. It looks like it's terrible. It looks like there's a ton of steps here. And I'm going to go through all these steps and kind of give you an example along the way. It is a lot of stuff, but with practice you get to the point where all of these things you just sort of know. Like tying your shoes, the first thing you do is grab both of your laces, and then you cross them, and then you put a loop, and then you do a little swoop, and then you pull. You know all those things, and you do it without even thinking. This method is the same way. Once you've had some practice, they all just sort of fall into place for you, and you won't even have to look at this list anymore. But I give you the list because if you forget, you can go back and see what it was that you were supposed to do next. So, the first thing you're going to do on problems like this, first of all, you see a problem, it says factor it, and you see that there's a number in front of the x squared term. The first thing you're going to do is look for a GCF to factor out first, greatest common factor. You always look for a greatest common factor first. That is step 1. You'll hear me say, what's step 1? As we're doing problems like this. And when you come back to Algebra 2, I'll say, what's step 1? Somebody walking by just now, I could go out there and ask, what's step 1? And I guarantee you, she will say, find the GCF. Want to try it? Here we go. After you look for a GCF to factor out, and that is why we did all of that factoring of GCFs for practice, because now it actually comes into play. What you're going to do is multiply A times C. That number right there, whatever that number is A. That number right there, whatever that number is C. You're going to multiply those two numbers together. And you'll write AC, you'll write AC equals whatever that number is. If you get 42 when you multiply those two numbers together, then you write AC equals 42. After you do that, then you're going to go back to what we were doing in the last section. Find two numbers that multiply to give you one thing and add to give you another thing. But the two numbers have to multiply to give you AC here. And then they have to add to give you B. And that's what step 3 says. Find two numbers that multiply to give you your AC, whatever that number was, 42. And they're going to add to give you this B right here, still. Once you have those two numbers, then you're going to set up the box. And you'll hear me say set up the box. In fact, I think he said set up the box. No, she said set up the box, right? So she knew what we were talking about. Set up the box. You're going to draw your box like we did before. But now for part A, it says place the first term in the first box. So that's the x squared term. This guy right here goes in the first box. Part B, place the last term, the constant term, in the last box. That's your letter C right here. So that C is going to go in the last box. Then place the two numbers from step 3. So these guys right here. These two numbers that you picked and you wrote them down. You would write them down right under that AC. That's what we're going to do. You take those two numbers that you picked and you put them in the other two boxes, but you attach the variable to them. So the variable in this case is x. So we'll write, like maybe my two numbers that I had to pick were 6 and 7 for some reason. I would write 6x here and 7x here. Or I could write 7x here and 6x here. It doesn't make any difference which order you put those into these two boxes. But it does matter which order you put these in. This guy, the first term, has to go in the first box. The last term has to go in the last box. And then the two numbers you pick go in the other two boxes in either order with the variables attached. Seem like a lot so far? This process right here takes about 12 seconds. Then the next step is to factor out the GCF across each row of the box and down each column of the box. So each row, we're going to factor out a GCF, and we'll write that answer here. Don't put a 0. That's going to look like a 0 if you put it in your notes. We'll factor out a GCF across that row and put an answer here. We'll factor out a GCF up that column and put an answer there. We'll factor out a GCF up that column and put an answer there. If the first box in the row or column is negative, so if this box right here is negative, that would be the first box in that row. This guy is going to be negative. This guy here is positive, this one's negative. So in this column, this term is going to be positive. Basically, the first box in the row, so the first box in the row, or the first box in the column, or the first box in the column. If the first box is positive, the term you factor out is positive. If the first box is negative, the term you factor out is negative. You'll see examples of that when we get there. The term across the top are one factor, the terms down the side are the other factor. So these guys right here form my first factor. These guys right here form my second factor. And that's me undoing FOIL right there. This is the answer. If there was a GCF that I factored out in the beginning, back in step 1, if I pulled a 2 out or something like that, then I'd put that 2 right there in the beginning of this problem, and then this is the answer. Okay? The GCF comes back in the answer, and we just write it out front times the FOIL problem undone. That's all there is to this. Seems like a lot, probably. After a couple problems, you guys are going to be like, oh, this is kind of easy. I hope. That's the goal. So, no better way to practice than to dive right in and do a problem. Factor 2x squared plus 5x plus 3. Well, notice first of all, this is a trinomial, And we have a number in front of the x squared term that is not just 1. There's a number there. So that means I need to probably use the box method. The first step in any factoring problem is what? Find the GCF. Factor out the greatest common factor. So look at these numbers. Is there a greatest common factor between 2, 5, and 3? Aside from 1? No. So there is no GCF to pull out here, which means we're ready to go. The next thing we have to do is find AC. AC is this number, the A number, times the constant number. So 2 times 3, which is 6. Now I have to think about two numbers that multiply to give me this number, the 6, and at the same time add to give me that number, the 5. 2 and 3, that's right. So I'm going to write those numbers down, 2, 3. Write them down, because now the voice is back on and I got to watch. And now I can stop right here and I can come right back to the problem and know exactly where I left off. Okay? Always check, double check your numbers. 2 times 3 is 6. 2 plus 3 is 5. You need to check those two numbers now, here, before you set up the box. Once you've checked those numbers, you know you're right up to here. Now you can set up the box. So you draw in your box. And now we place our terms in the box. What term goes in the first box? The first term, the 2x squared. What term goes in the last box? The last term, the 3. Now what goes in these two boxes? Yes, the numbers we picked, the 2 and the 3, but we have to attach the variable to them. So 2x and 3x. That's how you set up the box. So this first time it's taken longer, but over time we will start to go much faster to the point where you get the problem done very quickly. Okay, so the box is set up. Now what are we supposed to do? What am I doing with the rows and columns? Factoring out the greatest common factor. Now it does have to be the greatest common factor. It can't just be any old factor. It has to be the GCF. So what is the GCF of 2x squared and 3x? The greatest common factor between 2 and 3 is 1. The greatest common factor between x squared and x is x. So the GCF therefore is 1x, or just x. And now my bottom row, what's the GCF there? 1. There's always going to be a GCF. If you don't see one, then it's a 1, and you have to write down the 1. How about my first column? That is 2x. And my last column? That is 3. So now you've pulled out the GCF for each row and each column. We're ready to write our answer. This top right here, the 2x and that positive 3, is my first factor, 2x plus 3, times this side right here, that x and that positive 1, x plus 1. That's the answer. You're done. Since this is the first one we've done, I want to show you that what we get is actually what we started off with. So that means to check my answer, I need to do what? We need to FOIL. Yeah, factoring is what we did. FOIL puts it back together. So 2x times x is 2x squared. 2x times 1 is plus 2x. 3 times x is plus 3x. And then 3 times 1 is 3. If I combine like terms, I get 2x squared. So I'll write that here. 2x squared plus 5x plus 3, which is exactly what we started with. It works. It works every single time as long as you follow the steps. You have to factor out the GCF first though. If you don't, this can fail. But the good news is every method that you could possibly learn will also fail. So it's not like that's something different, okay? You always have to factor out the GCF if there is one first. All right, do you guys think you can talk me through the second one, or do you want me to talk through it again? Tell you what, help me out. What's the first thing we should do here? Always look for a GCF. 5, negative 13, 6, Is there one? Nope, not here. So what's the next thing we got to do? AC. So I'm going to write down AC equals what? 30. Okay, somebody tell me in words what's the next thing that has to happen. Two numbers that multiply to give 30, and they have to add to give negative 13. So think about those patterns we learned in the last section. What does that mean my two numbers have to be? Is one positive and one's negative? Are they both negative or are they both positive? They're both negative because we have two numbers multiplying to give me a positive. And we have to add them to get a negative. So they both have to be negative. That thought right there can lead you to the correct answer more quickly. It's worth it to take that second or two to think about what the signs have to be. Now that I know that they both have to be negative, what are my two numbers? Negative 10 and negative 3. So then write them down. Negative 10, negative 3. And then what do we do? Before the box, check to make sure. This is your only chance right here to check to make sure that you have the right two numbers. So negative 10 times negative 3 is positive 30. Negative 10 plus negative 3 is negative 13. Write those numbers down, then check them. If you're thinking about them in your head, sometimes your mind can play tricks on you. But if you see them, a lot of times your eyes will see that they don't work. So when you write them down, you can avoid that mistake. Now what do we do? Now you can draw the box. Yep, first box, first term, 5x squared. Last box, last term, it's a positive 6. Negative 10x, negative 3x. Can I put the negative 3x here and the negative 10x here? Yes, I can. It doesn't matter which order you write those two numbers. These two definitely matter. You have to have those in the right spot. But these two don't. You can switch them. It's fine. Okay. A little bit more challenging on this one. We want to factor out the GCF now. What do we have for that top row? Just x. The GCF between the numbers is 1. The GCF between the letters is x. So we pull out an x. How about that bottom one? Between 10 and 6, the greatest common factor is 2. But we have to remember the little rule that I told you guys. If that's a negative in that leading box, then the factor has to be negative. That's just the convention that the people who came up with this said. So we have to follow that. It has to be a negative 2 there. If the leading box is positive, like this one was, then that's a positive thing that we factor out. The leading box here in that row was negative, so we factor out the negative. Okay, how about this one? Positive or negative 5x? That one's positive because in this column, the leading box was positive. Even though that's negative there, this one's positive, and that's the one that matters. Positive, so positive. How about that second column? That one is negative 3 because the GCF between 3 and 6 is 3. That top box right there is negative, so that makes my factor negative for this column. That's the tricky part. Once you get that down, then pretty much you're going to be pretty solid on this box method thing. Sorry, I said pretty like 14 times there. Pretty. What's my answer? That's it. And since we're not confident in ourselves just yet, what should we do? We should check it. So I have 5x times x, which is 5x squared. Then I have minus 10x, and then minus 3x, and then plus 6. So the combined like terms, and I get 5x squared minus 13x plus 6, which is what we started off with. So we did it correctly. And that is the correct answer. What do we do first on that third problem? Look for a GCF. Do we have a GCF here? 7, 29, 4. Other than 1. No, we don't. Good. So, A times C, what do we get? 28. Good. All right, what happens next? Good. Two numbers that multiply to give me 28, and they got to add to give me what? 29. What two numbers do that? 1 and 28. So I write those down, and then am I supposed to just move on from here? Before that? Yeah, always check. This is your one and only chance to check to make sure you got those two numbers right. So 1 times 28, 28. 1 plus 28, 29. Are they right? Okay, what is the next thing we do? Draw your box, and go ahead and set that box up for me too. Okay, and does the order that I put those in there matter? These two right here don't matter. I could put 28x here and 1x here. That's fine. Okay. Across and down, across the rows and down the columns. But what is that we're doing? What are we trying to find? The GCF. You're looking for the GCF in the rows and columns. So, top row. 7x. And somebody else? It is just 1. Good. And somebody else? So we're on the first column now. What's the GCF? Look at the numbers. We got a 7 and a 1. What's the biggest number that goes into both of those? What did you say? I think you were right. Okay, 1. And then we got x squared and we got x. What's the biggest variable that goes into both of those? X. So we got 1x is the GCF, which means just x. Okay. You actually did it. And somebody else. Four.
Jenny.
What's next? So we read our answer. What is my answer? Good. And are we done? The smart thing is to check it to make sure that you're doing this right, especially in the beginning when you don't have much confidence. So, we need somebody to check this. Okay, so we FOIL, what do we get? Yep. Okay. Okay. And is that what we started with? Sure is. So now I can draw a box around that and be totally confident that I did it correctly. All right. So for this last one, I want to show you what happens as you get more and more practice done. Obviously, I've done a lot of these types of problems, and probably I've done this one 14 different times already over the course of the last few years, both in Algebra 1 and Algebra 2. So I do have a lot of practice, but I want to show you how quickly you can come up with the answer once you get it, okay? I'm going to talk it out as I go. This is like stream of consciousness in my brain right now. I'm not thinking about the video games I want to play later on, or the fact that I want to go golfing today after school, okay? Here we go. I'm presented with this problem, so I see that I have a number in front of the x squared term, which means that I need to look for a GCF before I try to start factoring. 5, 13, 6, No GCF to worry about there, so I just go straight to AC. A times C is 30. So now I'm looking for two numbers that multiply to give me positive 30, but add to give me positive 13. That would be 10 and 3. So my two numbers are 10 and 3. This is my only chance to check, so 10 times 3 is 30. 10 plus 3 is 13. I have the right two numbers. Draw my box. First box, first term, 5x squared. Last box, last term, 6. My two numbers, 10x, 3x. I'm ready to factor out the GCF. GCF here is just x. GCF here is 2. GCF down my first column is 5x. GCF down my last column is 3. I'm ready to go. 5x plus 3 times x plus 2. Done. And then I check. Notice the difference between these two problems. 5x squared minus 13x plus 6. 5x squared plus 13x plus 6. What was the difference? Yeah, the only difference here was the minus sign and the plus sign. That changed my numbers here and here that I had to select. The process is the same for all four of these problems, though. Once you know the process, you can do these problems with relative ease. 8 through 19L, that's like 12 problems. Make sure you are checking your evens with the back of the book. Make sure you're checking your odds with the back of the book, and make sure you're checking your evens by foiling it out. At least foil it out in your head to make sure that you're doing these correctly. There's no reason why you should have wrong answers on your homework, and really, if you're doing something wrong, you want to know about it right away, because otherwise you're just going to keep doing it wrong, and then what's the point? So again, we're just factoring here. It's a trinomial. I see a number in front of the x squared term, so I know I probably going to need to use the box method here unless I can factor out a GCF. But I need to check a GCF. So is there a GCF with 6, 22, and negative 8? Yeah, here it's 2. So I'm going to pull that GCF out. And this is where that skill for pulling out GCFs and then writing what's left over comes into play. So we have a greatest common factor here of 2. So I factor out the 2, open up parentheses, and now I write what's left over, which is 3x squared plus 11x minus 4. So if you're still doing the factor completely way where you go 2 times 2 times 2 times 3 times 3 times x, it's going to take you forever to get through problems like this. So you really do want to be doing this. Now, that GCF is just going to hang out. Now we're only looking at this. This is my A, this is my B, this is my C. So AC is what? Negative 12, right. We're just looking at this. So now I need two numbers that multiply to give me negative 12 and add to give me positive 11. What are those two numbers going to be? They got to multiply to give me 12. Positive 12, negative 1. Yeah, I heard it. So we have positive 12, negative 1. They got to be opposite signs because we're going to multiply to get a negative result. We got to add to get a positive result, so the bigger number has to be positive. 12 times negative 1 is negative 12. 12 plus negative 1 is positive 11. So we have the correct numbers. Always check here. Always check. Now we can set up the box. And in the box, still we're working with this trinomial right here. We're not going back to the original because it's not the original anymore. We factored out the GCF. So we go 3x squared in the first box, negative 4 in the last box, and then the two numbers we picked, 12x and negative 1x in the other two boxes. And then we proceed with the problem just like we normally would. The GCF for my top row is what? It's going to be positive because that first box is positive, and it's just x. For my bottom row, 4. 4 goes into both of those numbers, so 4. And how about my first column? 3x is right. And my last column, it's got to be negative because that first box was negative. And the biggest number that goes into 1 and 4 is 1. So then my answer is, don't forget the GCF hanging out front, 2 times 3x minus 1 times x plus 4. That's how you work a GCF problem. The GCF comes back in the answer, but in the meantime, you ignore it and just work with the trinomial inside. So we've split this trinomial into that, with that 2 still out front, just like before. Is there a GCF on this one? Aside from 1? No, there isn't. How about a GCF on this one aside from 1? Nope. How about a GCF on this one aside from 1? 5. Yeah, so we'd have a 5 that we pull out, and then our answer will have a 5 in front of that FOIL problem. Okay? So we'll do these problems next time, these next 3, and we'll finish the section off tomorrow.